Hello everyone. On this video I'm going to show you two things. The first thing, which is the paired t-test, and the second thing, which is the confidence interval command. I also want you to notice that you can always use two different data sets on the same do file. So let's say here we're using the fuel data set and we are clearing and then calling another data set, which is the auto data set. Okay, so on the same do file you can keep like importing and then clearing and then importing and then clearing and so on, so you don't have like to create multiple do files. Let's say you want to exercise with 2 or 3 data set, then you can do that on one do file. So let's start. So what I have here, I have been like working on something else, so I clear it. Okay, set more off and then set my directory, and then you create the log file, because this is where you save all your results. You name it an easy name. Every time I call it the same name as the data set. So data set is fuel, so this one is fuel.log. So log using, okay. The data set that we're using, we're getting it from the internet, okay, and this is the first time to learn something like that. Like our previous videos, I was showing you like a DTA file or an CSV file or an Excel file. So this time we're just calling the data set from the internet, okay. So we got the data set, okay. We have just two variables here. You can always check the data set. It's just a small one. It's just 12 observations and two variables, and one variable is the miles per gallon without fuel treatment, and then the other one with fuel treatment, okay. And then let's say you're interested in testing whether there is no difference between treatment and no treatment. So basically you want to perform a paired t-test to look at the difference in the values of two variables and testing whether the mean of these differences is equal to 0. Okay, so whether they are equal to each other, or you can say the difference between the two variables is equal to 0. It's the same thing. So here, as I showed you, you basically have two variables. You want to see whether they are the same. In other words, it doesn't matter that you're doing the treatment or not. So you test that by typing T-test, the first variable, equal the second variable, and then you execute it. So as we have seen last week, you get your null hypothesis here saying that the mean difference is equal to 0. In other words, there is no statistical significant difference between the mean of MPG1 and the mean of MPG2, or their difference, which is negative 1.75, is not statistically significantly different from 0. This is your null. This is what you're testing. All the p-values here are about the null, okay? And then if you have a high p-value, then you say I accept or fail to reject. And if you have low, then you reject and then you accept one of these three alternatives, okay? So let's say the question here is straightforward, whether they are equal or not. Nobody said whether MPG1 is greater than the mean of MPG2. So the format of the question, or the sentence here, gives us the impression that you just need to look at the two-sided test. Equal to 0, not equal to 0. So if I look here, the p-value is less than 5%, right? Because the 5% is 0.05. So this one, it's telling me that the p-value is less than 5%, or there is a small probability that the null is true. In other words, you basically reject the null because the p-value is small, it's less than 5%. So you reject the null and you accept the alternative that there is a statistical significant difference between the mean of MPG1 and MPG2. In other words, the mean difference is statistically significantly different than 0. Okay? If you want to be more specific, what makes sense to us is MPG with fuel treatment, right, could be like greater than MPG without fuel treatment. So you check here, and again the p-value is small, so you're saying there is a small probability that this is true. You reject the null, you accept the alternative that MPG2 is higher than MPG1, or the mean of MPG2 is higher than MPG1. Okay? If you look at the last alternative, this one is saying there is a high probability because it's higher than the 1%, 5%, 10%. It's 97.68%, so it's higher than all significance levels. And it's telling us there is a high probability that the null is true, right? So in that sense, you basically fail to reject the null hypothesis that there is no difference between the two means. As you can see, you have three different alternative hypotheses. It's always based on the question, whether I'm asking you whether they are equal or not, whether one of the variables is lower or higher. So it depends which one you're going to look at. It depends on the format of the question. Okay, so I'm writing here the p-value is, I'm talking about this one, which is smaller than the 5% significance level, and thus we reject the null and conclude that the mean difference between, it's not read and write, I'm sorry, I was like talking about something else, between MPG1 and MPG2 is different from 0, or not equal to 0. Okay, and I want you to notice that you can get the same conclusion if you use the 1%, right? Because the 1%, again, this value is so this number is, you can reach the same conclusion for reach the same conclusion for the 10%. Why? Because again, the 4.63% is still less than, right, the 10%. Okay? So you reach the same conclusion for the 10% significance level, but of course not for the 1%. Why? Because I'm sure that you know that 4.63 is higher, right, than the 1%. And in that situation, you basically you're gonna say fail to reject the null hypothesis. So under the 1%, you fail to reject because there is a high probability, higher than what? Higher than 1. There's a high probability that that the null is true. But if I'm comparing it with the 10%, I'm going to say no, there is small probability, and I'm going to reject the null. Okay, so you're rejecting the null under the 5%, under the 10%, but not under the 1%. Again, as you can see, you have different conclusions based on different significance levels. But again, in that situation, the question would be specific and tell you which significance level you use. Otherwise, if I don't tell you, then you can choose your own, right? If a student is using the 5%, he or she will have a different answer than a student, right, using the 1%. But I would always be able to see your answer and determine which significance level you are using or referring to. Okay. After you're done, you log close, right? And you're done. Now, if I want to use another data set, so I'm going to clear because I want to remove this from here, right? So you want to clear, so you clear the data set. So once you clear it, it's gone from here. And then you create a different log file because you want to create another file where you're going to save the coming commands. And then again, here I'm calling it from the web, right? So I have information about different cars, the make, the price, MPG, right? The number of weight and length and displacement and so on, right? So you have all the information here, and you can always, as I said, you can always open the data set and read it, okay? You have the labels here, okay? And this is in addition to the description that I send or that I post on Canvas. So let's see here. What we're going to do is we want to perform a 95% confidence interval. So how can we do that? You just type CI. CI stands for confidence interval, and then you type the word means, and then let's say I chose the variable MPG. So you type this one and then you execute it. What you get here is a straightforward answer. MPG, 74 observations, this is the mean standard error, and this is the confidence interval that we need. And anytime you're typing the answer, it needs to be in square brackets, right? So CI, the confidence interval of the MPG, has a lowest value of 19.96 and a high value of 22.64, right? You approximate. Now, suppose that you want to perform the 99. If you don't say anything, then the default is 95. Suppose that I'm asking you to get the 99. All what you need to do is just to place a comma, level 99. Suppose I want to do for two variables at the same time, MPG and price. So you type them next to each other, and then you execute it, and then you will get it like that, right? So this is the confidence interval. Again, you write it in square bracket, as you can see it here. And the price, again, it's here, so you write it in square bracket, and then you're done. So this is the 99% confidence interval. What else? How about if I want to be more specific? I want the 99% confidence interval for the variables MPG and price, but only for foreign cars. I really don't care about the domestic cars in this command, so I'm just focusing on foreign cars. And if you want to do that, you just have to add the command if foreign. And what you will get is just related to foreign cars. And as you can see, the observations are less than the previous ones, because now this observation, 74 observations, is a mix of foreign and domestic cars. But now I'm just focusing on foreign cars. So that means 22 out of the 74 are foreign cars, and we have the remaining, which is the 52 remaining, are domestic cars, okay? So again, this is the 99% confidence interval for specific group of cars, which is the foreign cars, okay? And then again, you have the confidence interval. You can write it in between brackets here, okay? And we're done. So this is what we need to learn for this week in terms of this is just an additional part. So in terms of the confidence interval, what you have also in this week's practice, some of the commands that you have learned last week about the t-test with equal variance, unequal variance, and so on. Okay? All right. If you have any question, please post on the discussion forum. Thank you.